Alright, friends, grab your coffee, because today we're tackling one of the most mind-bending questions in the universe. What happens if you actually, truly fall into a black hole? It sounds like something straight out of a sci-fi movie, but the science behind it is even wilder than fiction. We're going to break down this cosmic journey, step by step, from the moment you approach one of these gravitational monsters to your inevitable, spectacular demise. So, buckle up, because things are about to get really, really strange. First things first, what exactly is a black hole? Imagine a star, way more massive than our Sun, collapsing under its own immense gravity. It shrinks down to an incredibly tiny point, but its gravitational pull remains the same, just concentrated. This creates a region in spacetime where gravity is so strong that nothing, not even light, can escape. It's like a cosmic drain, sucking in everything that gets too close. Wild, right? Now, as you approach a black hole, you'd eventually hit an invisible boundary called the event horizon. Think of it like the lip of a waterfall. Once you cross it, there's no going back. It's the point where the escape velocity, the speed you'd need to get away, exceeds the speed of light. Since nothing can travel faster than light, you're trapped. From your perspective, it might feel normal at first, but everything on the other side is heading towards the center, forever. Okay, this is where it gets really gnarly, spaghettification. As you fall feet first into a black hole, the gravitational pull on your feet would be much stronger than on your head because they're closer to the black hole's center. This difference in gravity, called a tidal force, would stretch you out like a noodle, literally. You'd become a long, thin strand of atoms, hence spaghettification. It wouldn't be pretty, and it would happen incredibly fast, which is a bit of a grim comfort, I guess. The kind of black hole you fall into actually makes a big difference in your experience. Stellar black holes, born from collapsed stars, are relatively small, maybe 10 to 20 times the mass of our Sun. Their event horizons are tight, meaning spaghettification hits hard and fast. But supermassive black holes, like the one at the center of our galaxy, are millions or even billions of times more massive. Their event horizons are much wider, so the tidal forces are less extreme at the point you cross. You might survive spaghettification for a little longer, but the singularity still awaits. Here's another trippy part: time dilation. For anyone watching you fall from a safe distance, time would appear to slow down for you as you get closer to the event horizon. You'd seem to freeze, becoming fainter and redder until you essentially wink out of existence, never quite crossing the event horizon from their perspective. But for you, the person falling, time would continue normally. You wouldn't perceive any slowing down, it's everyone else who sees you taking forever. Talk about a cosmic paradox. Once you've crossed the event horizon, and if you haven't been entirely spaghettified yet, your ultimate destination is the singularity. This is the very center of the black hole, a point of infinite density where all the mass is concentrated. All known laws of physics break down here, and what exactly happens is still a huge mystery. It's not a place you can visit and then leave, it's more like an inevitable future, a point you can only move towards. There's no turning back, and no bottom to bounce off. So, to sum it up, if you fell into a black hole, you'd first hit the event horizon, the point of no return. Then, you'd be brutally spaghettified by insane tidal forces, stretching you into a thin strand. From an outside perspective, you'd fade away as time slowed for you, but for you, time would just keep ticking until you reached the mysterious singularity, where physics as we know it ceases to apply. It's a one-way trip, a spectacular and terrifying end to any journey. Definitely not on my vacation list, that's for sure.